This week's videos will all be about polynomial regression, and as a first step, I want to show how we can simplify the process of performing polynomial regression by using this helper class in scikit-learn for making polynomial features, which is like powers of x. And if you had two different features like x1 and x2, it would also help you make powers like x1 squared times x2 cubed. But in our case, there's just going to be one input variable, the x. So I have this data set with 1,000 points. They started out on a parabola, and then I added some random noise to it. But the true underlying polynomial is degree 2. And in this video, and probably in the future videos, I'm going to be looking for a degree 10 polynomial. So let's go ahead and see how we can do that using polynomial features together with linear regression. So we're going to say from sklearn.preprocessing, import this polynomial features class. And we also need to do linear regression. So we're going to say from sklearn.linearModel, import linear regression. And so the first thing I want to do is show you how this polynomial features works. So as an example, say I take, how about poly is the name I'll call it, and I'll instantiate it with this polynomial features. Okay, so this works very similarly to how standard scalar works. Like we instantiate, then we fit, then we transform. So, and I should have said what the degree is going to be. So we'll say degree equals 10. And then let's try poly.fit, and how about just 1, 2, 3? And here's the usual error that we get all the time with scikit-learn, where it wants the input to be two-dimensional. Okay, and so I want this to be like a column in a pandas data frame. So instead of a row, so that's why I'm adding all these little length 1 lists inside of this list. Okay, and now we can, let me just copy this and paste it. Now we can do transform. And so what you should expect is we're going to see, for example, 1 to the 0th, 1 to the 1st, all the way up to 1 to the 10th. And then we're going to see 2 to the 0, 2 to the 1st, all the way up to 2 to the 10th, and so on. Okay, so here are the 1s. Okay, here are the 2s. Goes 1, 2, 4, 8, 16, 32, and so on. And here are the 3s. Okay, maybe it would be easier if I started with, how about just degree 3s so we don't get this exponential notation? Okay, now it's a little easier to see. So we get, for example, 3 to the 0th, 3 to the 1st, 3 to the 2nd, 3 to the 3rd. Okay, great. And so let's go ahead and instead of doing polyfit on this little make-believe 1 by 3 by 1 shape, let's fit on, I think I called it df full, and on the x column. And so right now we'd get that exact same two-dimensional expected error. So I have to put these double brackets. Okay, great. And now let's just save this, how about as poly output equals, and now we transform this. So it's going to be just like what we had up here, but with 1,000 different rows instead of 3 rows. And let's go ahead and change back to degree 10. So I'll do poly equals polynomial features, degree equals 10. And I'd also like to get rid of this initial column of 1s. So to do that, I'm going to say include bias equals false. Okay, and what have I done wrong? I don't have the word transform here. Okay, great. And so let's just see what the shape of this poly output is. So it is 1,000. Okay, that corresponds to my df full dot shape having 1,000 rows. And 10, that corresponds to the first power, the second power, all the way up to the 10th power. Okay, great. And so now we can use linear regression. So we'll do reg equals linear regression. And then let's do reg.fit. Okay, and I want to have access to these different polynomial features, to the powers, so I need to do this fitting on the poly output. Okay, not just on the x column. Okay, so we'll do poly output, and then let's have df full brackets y. Okay, those are the true outputs. Okay, great. And so up here, I called this alter chart C. And let's go ahead and see another version of this. So let's save this as, how about df full the y prediction column. Okay, that will be reg.predict poly output. So think of this as the outputs of our degree 10 polynomial. So like we're going to plug in x to this degree 10 polynomial, and then the outputs will be stored in this new column here. Okay, and let's change this to C1. Let's change the circles to a line, so mark line. Let's change the color to, how about red, to make it a little easier to see. And let's change the y values from these y values that follow a degree 2 polynomial plus some random noise. Let's change that to y pred. Okay, that follows our degree 10 polynomial of best fit. And then let's see these two layered on top of each other. So there is our degree 10 polynomial fit. And there's probably a little bit of overfitting with this. Like, I'd say it doesn't look super natural, but looks okay, I would say. And if we want to see what the coefficients are, so we can look at reg.coef. And so you should think that this is going to be the coefficient of x. This is going to be the coefficient of x squared. This is going to be the coefficient of x to the 10th. And the fact that these numbers for the bigger degrees are getting so small, that's a good sign that we're not overfitting too badly. And the reason we're not overfitting too badly is because we have 1,000 data points. In general, the more data you have, the more robust your model is going to be to overfitting. Okay, so it's going to help you avoid overfitting if you start with lots of data. Okay, so we'll see some examples of how using less data, okay, using fewer data points, how that leads to more overfitting in the next video.